Hello everyone. I is Rangeshwaramma, Assistant Professor, Department of EC, Gates Institute of Technology, Gutti. A very warm good morning to one and all. I heartily welcome all the participants and speaker for the Day 4 session on the topic Wearable Devices, Potential Breakthroughs and Transformative Technologies. Now I request Dr. Achak Praveen sir to introduce Day 4 speaker, Dr. SANYOG RAWAT sir. Sir, please.
Very good morning to one and all. Today's topic is wearable devices, potential breakthroughs, and transformative technologies. I'm introducing Dr. SANYOG RAWAT, who is the Associate Professor and Head of the Department of Electronics and Communication Engineering at Central University of Rajasthan, Kishangarh, Ajmer. Sir have graduated with Bachelor's of Engineering in Electronics and Communication, Masters of Technology in Microwave Engineering, and PhD in the field of planar antennas. He has been into teaching and research for more than 19 years. He has published more than 100 research papers in reputed journals and conferences and several book chapters. He supervised 8 PhDs till date and currently 3 are underway. He has supervised more than 30 MTech dissertation works. He has been member of Technical Program Committee of many IEEE Springer conferences and reviewer of reputed journals like IEEE, Elsewhere, Whaley, Springer, etc. He has also edited the book on proceedings of International Conference on Soft Computing Theories and Applications, SOCTA 2016 and 17. Proceedings of International Conference on Smart Systems, Innovations and Computing, SSIC 2017, and International Conference on Engineering Vibration Communication, Informative Processing, ICO EVCI 2018, and International Conference for Wireless Communications, ICCWC 21, 22, 23 for Springer publication. He has extensively traveled to countries like Japan, Singapore, Malaysia, Vietnam, Indonesia, Thailand, and UAE to deliver talks, present research papers, or in connection with other research academic activities. He is Life Fellow of Institution of Electronics and Telecommunication Engineering, IETE, India, and Life Membership of Institution of Engineers, India. Indian Society for Technical Education, ISTE, and Indian Society of Lighting Engineers, ISLE. His current research interests include RF and microwave devices, microstrip and smart antennas, and reconfigurable antennas. Sir, I welcome you, sir.
Thank you.
Sir, you can start the session, sir.
Okay. Thank you so much. So, I'll share. Is the PPT visible to you? Is the PPT visible?
Yes, sir. It's visible.
Okay. Okay, so good morning, everyone. Esteemed colleagues, students. So, my today's topic is wearable devices, potential breakthroughs, and transformative technologies. So, this is the table of content. So, we'll be discussing about overview of wearable devices, applications in healthcare, wearable nanotechnology for drug delivery, energy harvesting for self-powered wearables, then wearables in augmented reality and virtual reality, feature scope and conclusion. So today we embark on an exciting journey into the world of wearable devices. The wearable devices are the devices where the cutting edge technology intersects with the healthcare and communication. These versatile devices
Sir, excuse me,
have,
sir.
yes,
PPTs are not changing. I mean, slides are not changing, sir.
okay. Is it changing now?
Sir, no, sir. It's in first slide only, sir.
Now?
No, sir.
Let me make it. Is it visible now?
Now it is changed, sir. You can keep full screen, sir.
Okay. Is it visible now?
Yes, sir.
Okay.
Thank you, sir.
So, okay. So, wearable devices, I can see, is defined as the devices that we worn in our daily lives. This could be of any form. This could be a watch, it could be an eyeglass, it could be a belt, shirt, and these devices, they have, I mean, we nowadays we are using cutting edge technology, which could be used for healthcare and uh, communications. And these, I mean, gadgets, which we call as wearable devices, they have demonstrated so far a very profound potential in transforming the landscape of modern healthcare. And they are also offering unparalleled convenience, accessibility, and accuracy in the health monitoring. Furthermore, I would say that they have facilitated seamless communication between the patients and healthcare professionals and breaking down the barriers. Uh, we can have telemedicine, so they are also transcending the geographical boundaries. So in this presentation, we are going to explore the applications of uh, wearable devices primarily in the healthcare, and we will also going deep into their impact on other areas as well. So our primary focus would be the healthcare and communication, which could include patient care, remote monitoring, and future of digital health. So we know that these devices have become very popular nowadays. All of you must be using a smart watch. So smart watches are something which are easily available. The prices have also come down. They're less than 20,000 to 2,000, I would say. The reasonably good smart watches available, and we generally use it for various purposes. Like the smart watches, they are equipped with now fitness tracking features, activity monitors. Now the next level after the smart watches has come here, a medical grade wearable patches. Those patches are basically used for continuous monitoring. Since I'm from antenna background, so somehow whatever topic I'll take for the presentation, antenna comes into picture. And being a background from I've worked in antenna for past few years, so they are of I would say these are the of special interest to me. And now, apart from the smart watches, there have been even smart clothing and embedded sensors. They've also come into picture. So when we talk about sensors, I mean, one of the most significant role what wearable devices are supposed to do, particularly in the case of health monitoring, is is these devices can actually accurately track your vital signs, such as heart rate, blood pressure, respiratory rate, your body temperature. All those things could be done. So they are actually providing user with a real-time insights into their physiological status. Additionally, these wearable devices are also invaluable in chronic disease management. So if I take an example like people who are living with conditions like diabetes, asthma, hypertension, or I would say cardiovascular diseases, they can be also benefited from wearable. And they have now we have a non-invasive way of glucose level measurements also. So what they do is their ability to monitor glucose levels. They can also detect the potential threats, and they can deliver timely alert. They are also enhancing the self management and also reducing the burden of hospital visits. So what I could say is that wearable devices are playing a very, very vital role in our lives for our health practices, also for our healthy lifestyle choices with the features like step counting, sleep track, stress management, and it actually empowers the user to make informed decision to improve their overall well-being. So they have also found health applications in mental health, which is a very very important area, and a lot of work has been going on in this area in the past few years. So like physical health, uh, mental health is of also paramount importance. So they are assisting in stress reduction, anxiety management, and meditation. Further, these I would say wearable devices could be, as I already mentioned, they could be used for emergency response situations, since they are equipped with the built-in communication capability with emergency alerts. So these devices can quickly send a distress signal and vital health data to the designated contacts. The designated contacts could be a relative, could be a close person, could be a medical professional, which actually leads to a swifter medical interventions and potentially saving the lives. So these are, some of the examples. And is the slide visible? The next one, the IoT enabled sensor system. Can you see the slide?
Yes, sir. It is in third slide only, sir.
Okay, is it the IoT enabled and sensor system is not visible? I think I should
Not visible, sir. It's not seen. It's not visible, sir.
now.
Yeah,
Is it?
now it is changed, sir.
So I
Yes,
think
sir.
I
Now
should
it
keep
is
it.
visible, sir.
Okay, so I'll not change it. I'll keep it in this mode only, because when I'm going for full mode, it is not changing. I don't know
Okay,
why.
sir. Okay. Okay, sir.
So is okay.
Okay.
So this is what is just an example of an IoT enabled sensor system, which can monitor the physiological and clinical parameters, and which are promising for the smart healthcare. As I already mentioned that the equipments now, if you can see this, there's an implant near the head. Okay, there is an implant uh, near your heart. Then that object is wearing a patch also, and there is a smartphone there's a smartwatch, and finally this data goes to the server, and we can send the alert to the, I mean, apart from the data going continuously to the server, it goes to the family member, it goes to the medical professionals. So as I said that it leads to it can potentially save our lives. And the features it could have is preventive medicine, diagnostic, prognostics, rehabilitation, therapy. So these are the various features, or I would say that these are the objectives which we could achieve by using wearable devices. Moving next. So this is a complete solution. This is basically a comfortable bio shirt which contains a respiration sensor and fabric electrode to wirelessly record both respiration and ECG. And it is while doing so, the subject can move freely and they can perform the task in short or long term studies uh, in the label or in the real world. So the shirt actually connects to a wireless respiration and ECG transmitter, which is placed in a small pocket on the front of the bio shirt. And the advantage are there are no electrodes, no gels, no wires to fuss over, and even it can transmit data to either a standalone smart center or with the matched receiver module. So that is the advantage of this BioShell. This we, as I already mentioned, we already use it. It's a wearable non-invasive sensor. So as you can see here, photo detectors are being used for the oxygen sensing, and the monitor does the ECG. So the three things you can see: the electrocardiogram, which is ECG, your cardio fitness level, and also the blood oxygen level that can be shown. And it is I mean, majority of us are now using this. So basically this is a wearable non-invasive based sensor system which is based on photo detectors and a crown monitor. This is again a very popular device. It's a wearable sensor based continuous glucose monitor. So as you can see that it can continuously monitor your glucose level through this device, and it's also available in the market. You can, I mean, online shopping websites have this device. So this is another device. As I already mentioned that uh, people who are having diabetes or any other disease, for them these devices are very useful, because a diabetic person, the difference between a diabetic person uh, and a non-diabetic person, I'm not from the medical background, but whatever knowledge I have is that in case of a diabetic person, there is a huge variation in their sugar level. So maybe, I mean, the sugar level fluctuates a lot and the variation is a lot. While for a non-diabetic person, the variation is within certain limits only. So suppose you take your glucose level at the fasting, maybe it will fall at 120, and it comes around 120, say after breakfast. If you take maybe after 2 hours, then also it will not go, it will be say 140, 160, that's okay. But for a diabetic person, maybe a fasting could be as low as 60, and maybe after breakfast, if you take, it can go as high as 200, 300, could be 400, it depends. So that is a huge variation. Now, with this device, you have an advantage that it can keep track of your sugar level. If you can see this, it shows that how your sugar level is varying, right? So you'll get to know that at what point your sugar level uh, is the highest or is the lowest, and if your sugar level is low, then you're supposed to take some glucose, something. So even a high as well as low, both uh, sugar level are not good. So that's a very useful device, I would say, which could be used for monitoring the sugar level. That's another way of glucose monitoring. That's a non-invasive ways. Recently, I don't know how many of you have uh, saw that in the news. It came in the newspaper also that bits Pilani, few researchers have come up that a glucose level could be measured from the sweat, and I think they have already filed a patent, and they are going for the startup also as well. So now we are going for, instead of taking the blood sample and then taking a glucose level, now we are looking for the ways where we could do non-invasive way of glucose monitoring. So this was the work uh, done by Professor Call and group in the year 2021. Okay, and this is one way of non-invasive way of glucose monitoring. So you can see that there is a glucose measurement center, which is between your thumb and finger, and then it goes to it. It actually works on the principle of reflection measurement. It works on the principle of reflection measurement, and you'll see that there is a kiosk machine. So the measure data, actually what happens is, um, like suppose I want to use any antenna for the measurement. So like an antenna in free space, what is the response of an antenna, will note down. The next is, we'll put it in the uh, environment, or maybe in the close vicinity of certain object. Then also we'll check the radiation performance of an antenna. And this radiation performance, there are various parameters for the radiation performance. Uh, the radiation performance could be your resonant frequency. The radiation performance could be bandwidth. It may include polarization and also the gain. So all these parameters of an antenna in a free space is being taken down. Then when you keep the antenna in close vicinity with certain object or in another environment, that we take down. Now, whatever deviation that you see in the parameters, that deviation is actually giving you the information. So it's like a database where all those deviations are being kept, and then what you do is, once you have kept an antenna or a sensor, whatever you call it, the sensing device, you keep it there, and then you check out the deviation, and that deviation is meshed with the database. So if it is matching with any of the database value, then we correlate that if this is the value, then this is the level. So it is like, in this sort of glucose monitoring, you are first sensing the data, then we are acquiring the data, then we are applying the machine learning to correlate it with the available database, and then we are reaching out to the conclusion. So the frequency band which is being used here is actually sub-terahertz frequency band. So that is why it is called as sub-terahertz non-invasive glucose monitoring device. So this actually this particular work, uh, I had been to a conference where Professor Call had come and he had presented his work. So it was actually taken from that. That's another work. So it is again a non-invasive glucose monitoring system. Now here we are taking two parameters. One is S11 and S21. The process again remains the same. So we'll note down the S11, S21 because this is port 1. This could be port 1. This could be another port. So now whatever variation in S11 and S21 is observed with this, then again the same process, the data will be acquired, then it will be matched with the available database or whatever database we had created by taking different types of samples, and then we reach out to the conclusion. So this is again another, so the kind of sensors which are using, as you can see that it is a sub-terahertz waveguide sensor. So because of the use of sub-terahertz waveguide sensor, we are using it a sub-terahertz non-invasive glucose monitoring. Now this is again a very interesting thing. This is a functional near infrared optical brain imaging system. So this functional near infrared optical imaging system, this actually measures the oxygen level changes in our what we call as the prefrontal cortex of human subjects. So each system actually provides real-time monitoring of the uh, what you say that tissue oxygenation in the brain. So as a subject take rest, or when it performs any task, or it receives stimulation, and allows researchers to what do you quantitatively assess the brain functions. Those brain's functions could be, I would say, like attention, memory, planning, problem solving. So, what we say is, while an individual is performing the cognitive task, this device actually provides a relative change in our hemoglobin level, and it is actually done by using there's one famous law which is also called as the modified Beer-Lambert's law. So that is being used, that will be used for this. So how does it work actually? So let me take you to another slide. Is the slide visible?
Yes, sir. Slide is visible, sir.
So,
So session is up to 12:30, sir.
yeah, I know that.
Yes, sir. Thank you, sir.
Okay. So here the subject actually wears an sensor uh, which is basically uh, it has an infrared light source and detectors which are mounted in a flexible bend on the forehead, which actually, what do you say, that it detects the oxygen level in again our cortex, which is also called as the prefrontal cortex, and it actually provides the real-time values for what we call the biological terms. They are oxy hemoglobin and deoxygenated hemoglobin. So basically, it provides a continuous and real-time display of the oxygen changes as the subject performs different tasks. So what I can say is the subject can sit in front of a computer and take a test or perform a mobile task. So you can see this band. So there is a laptop uh, which is actually meant for data acquisition, analysis, and display, which has a wireless receiver. There is an integrated battery. You can see that there is a battery the subject is holding. Then we have the sensor cable. This is the cable. This is the cable. And then there is a sensor pad. So this is the sensor pad it has, and this is the sensor cable. So in this case, as you can see that there is a light source, which is basically an IR light source, and this is there is a detector which is mounted on the flexible bend. So let me go back to the slide. You can see this. So there is a light source. There is a optical detector which is on the cortex of the brain, as it is visible over here, and they are basically used for real-time monitoring of tissue oxygenations. And these oxygenations are, as I already mentioned, they are very, very important. Why they're important? Because they are the one which are responsible for many of the brain functions. I mean, the way you will, um, again, the same process. So when you are in stress, say you are solving or doing something which is a difficult one. So how your brain or these, what are the levels that will be noted down. So when you're walking, when you are memorizing something, when you are listening to something with a lot of attention, when you are doing meditation. So all, I mean, at for the different activities, the values will be noted, and then it will match with the samples or the database that has been taken, and whatever deviation is being found, that deviation will be, through that deviation will draw the conclusion that this is, if there is something wrong or something is there, then that could be noted through this. So I mean, this could be used again in remote patient monitoring, because remote patient monitoring is something which has emerged as a very, very transformative approach in the healthcare. As already mentioned, that it is particularly managing the what I say, that chronic diseases and also the post acute care. So our wearable devices, they can play a pivotal role in enabling the remote monitoring of the patients by continuously collecting those um, and transmitting the patient's data to the healthcare providers. Even I would say in the field of telemedicine. So I think probably no after this, yeah, this is one. We know that walking is a central activity of our life, and there has been increased demand for objective measurement based gait assessment. So what is gait assessment? Gait assessment is a way to assess the dynamic posture and what we say the coordination during movement. That is what is called as the gait assessment. So in contrast to stationary systems, this particular slide shows that our wearable devices, they have the potential to what we say that enable a non-restrictive and accurate gait assessment in our daily lives. So a set of algorithms are being used for the measurement of the 2 foot one. Then we could have an variable inertial measurements unit, which will determine the gait parameters uh, which are essential for the clinical gait assessment, and that can also give you information regarding the duration of what we call as the 5 gait phases. So your apart from this, it gives you information about your stride length, your walking speed, and also about cadence. So all those information could be obtained, and how that is being done. So a transducer is basically being used here to record the heel and toe strike activity. As the subject walks, the heel and toe strike activities is being taken or recorded by using a transducer, and this data of heel or toe strike is actually recorded on 2 analog channels. So one channel is basically it will record the heel strike, and another will record the toe strikes. So these strikes are actually are the indications which are indicated on the graph. And as you can see here, two force resistive sensors are attached to the sole of the shoe. So they use two transducers to record both the feet. Two transducers are being used for recording both the feet. So that is, something which is very popular nowadays, because everyone is so particular about their gait assessment, and they wanted to uh, improve it, rectify it if there are any issues with that. So this could be done by this device. Next, we are going to show the what is called as the drug delivery. So drug delivery is something which is again a very important area, and this is something which is a lot of work has been done in this area, particularly to uh, drug delivery, what we say. So if you look at this slide, you'll find that it has got two parts. One is the wearable devices, another one is the implantable devices. So on the left, we have the wearable devices, which includes the pharmaceutical jewelry. Then there is an ocular ring. There is a drug delivery mouth guards. There is a drug-eluting contact lens. Then we have a wound healing patch. Earlier, we used to, a wound healing patch is very, very popular. I think in majority of the hospitals, they have started using it, a wound healing patch. Then we have a drug-loaded self-care textiles also. On the right, we have the devices. These are the devices which you can wear. These are uh, on the body, and the right ones are which could be used inside our body. So the drug eluting coronary stent, then the drug eluting ocular microstent, then there is a hydrogel depot with drug cells, then there are magnetic pump with drug reservoir, then we have another injectable hydrogel based drug depots, then intrauterine devices. So these are all being used. In fact, we can consider them under the what we say, it may be considered under the telemedicine and communication. So telemedicine is something which has a lot of advancement has been going on in the field of telemedicine using these wearable technologies. So because of these wearable devices like smart watches, wearable cameras, we can have video consultations and uh, remote diagnostic capabilities. So it is actually making doctor-patient interactions seamless and efficient. So patients in remote or unreserved area, they can now access specialized medical expertise without the need for the physical visits. So that has actually improved the healthcare accessibility, and also they have reduced to some extent the healthcare disparities. So what we could say is that wearables have actually enhanced the patient communication with health professionals, and also it is fostering the continuous and personalized care. So through wearable based communication platforms, uh, patients can easily what we say easily communicate their health concern, receive feedback on treatment plans. What we can say that they can be stay informed about their health progress, or this will also improve um, the pay. What we say that there is a patient doctor relationship has also improved. It also leads to the patient's satisfaction because it actually leads to better health outcomes. So why do we use the wearable nanotechnology? So wearable nanotechnology is also being used for drug delivery. So what is the reason for that? So the if I say the background is that we all know that the poor adherence to drug dosing schedule is actually the main factor for 50% of the hospitalization cases. So most of the patients, they actually fail to adhere to a strict dosing schedule, and this leads to their hospitalization. And so, in order to improvise that, we are actually using the wearable devices, or wearable devices and implantable devices, or combination of the two. So devices which could be wearable, which could be also implantable. That so this has actually created uh, uh, a new avenue or new area for treating patients which are having chronic disease, and where what we say that uh, repeated doses are required, full-time medical attentions are required. Those diseases could be wound healing, any cardiovascular disease, and any disorder, diabetes, all those things, they come under this. So these wearable devices which are being shown on the left, they are actually worn on the body surface, and they have created um, they work on a non-invasive method. So if you can see, there is a microneedle skin patch, there is a wound healing patch. So all these are devices are very popular, which are used for drug delivery. So where do we use this implantable? We know that the stunt, when in angioplasty, the stunt is being used because whenever a patient has a blockage, so there are two ways to clear the blockage. One is angioplasty, another one is bypass surgery. So in this case, wherever the surgery is taking place, then we use the implantables which are shown on the right. So what is the advantage of these implantable? So one thing is they have a localized effect. Even a pacemaker is an implant which is being used. Pacemaker maker is something which every one of us knows. So these stunts, these the other devices which are shown over here, they 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 have been in use like a pacemaker has a life of 5 to 10 years. So they are, I mean, what I would say that the wearables use in drug delivery has got a very exciting future. We have a very miniaturized and a very small nano devices which can be integrated into uh, the wearables, so that they can offer a targeted and controlled drug release. And also they are, I mean, they can optimize the treatment efficacy, and also minimizes the effect because it is the localized drug delivery, like this one. So it is a controlled drug delivery system. It's an endoscope capsule, and it has got various parts like an antenna, battery, electronic component, micro reservoir, micro needle, and a drug. Okay, so uh, this actually does, as I already mentioned, it does the job of uh, a particular control delivery, and is very helpful in chronic diseases like cancer, diabetes, neurological disorder, Now nanorobots is something which is also being used for this. Now, since we have talked so much about these variables, now a very big question on these variables is about from where they'll get the power. Like you can see that we have to connect a battery. So is it possible to have the energy harvesting using variables? So this is, I would say, a very good area for the research. So we know that our human body, it has got an abundance of available energy from the mechanical movement like walking, like jumping, running. So we've got many devices which are electromagnetic, uh, like piezoelectric and triboelectric energy harvesting devices, which have demonstrated actually to convert the body mechanical energy into electricity. So this can be used to power various variable and implantable electronics. So what we want is we want these variables to be self-powered. We don't want to have give them power. They should be self-powered. Now the challenges in this area are um the complicated structure, or I would say the high cost of production or maintenance, and limitation of wearing and implantation sites. So what is required is a self-powered system is being required, and it should it should actually use the energy, uh, the biomechanical energy of a moving human body, which can be harvested through a piece of electrode attached to the skin. So this is one which is using, it is basically a body integrated self power system. You can see. So what is the basic principle of this system? The basic principle of this system is that it is the comprehensive effect of what we say the triboelectrification between the slow soul and the floor, and it is what we say is uh, electrification of the human body. So what we can say that the energy harvesting technologies are basically offering a very innovative and sustainable approach to powering the wearable devices. So these systems actually can harness and generate power from diverse sources. Now those sources could be what? The sources could be body heat, motion, ambient light. Uh, so that makes them variable devices into a self-sustaining entities. So once they become self-sustained, because that is again a big question, from where the power will come. So it actually solves our problem for frequent battery replacement. Nowadays, in pacemaker, uh, battery replacement itself is, or basically it is again a surgery. So we want to uh, remove those issues. So energy harvesting is an area where a lot of work has been going on. So it actually enhances the user experience, and also it extends the what we say that operational life of wearable. And further, uh, this this energy harvesting, it actually what we say that it leads to more applications of variables, particularly in a resource constrained environment, or I would say in a remote environment where it is not possible to give external supplies. So in that case, there is a lot of scope which is available, particularly in the case of variable. So that is area where a lot of work has been going on in case of variable. Now we are going to talk about something which is called as the augmented reality, or variables in used in augmented reality and virtual reality. So this particular slide gives you a lot of information about the work which is going in the area of uh, augmented reality and virtual reality. So actually integration of wearable devices with augmented reality and virtual reality, it is it is it has actually opened up immersive experience that transcends the boundary of reality. So by coupling what do you say augmented reality glasses and what we have is Oculus, the virtual reality headsets with the wearable, a user can gain seamless access to critical information and immersive virtual environment. So we can say that the implications of this integration, it could extend to various diverse fields. It could be for education also. It could be for entertainment also, for productivity. So what we say is that the human sensory system is one of the most what we say cardinal component of human body. So it actually assists humans to survive, adapt, flourish in difficult and extreme environments. So this ability of the human body to sense temperature is one of the critical attributes, okay, which helps it to what we say perceive and interacts with the external environment. So it is called as thermoception. So thermoception is is the ability to perceive temperature or the sensation of cold or warm. So as you can see here, there is there is written that there are thermosensors, thermo technology for AR VR. So we are talking about this. So it actually can be effectively utilized uh, um, um, to what we say is to manipulate the user's perception by using various uh, mediation and augmentation technologies. So this thermoception is also actually influenced by uh, other multiple sensor perceptions. Those are we call it visual. So in this the kind of sensor which we make here is actually to make humans feel like real. So these sensors are basically used to create a virtual reality environment so that they can feel, they can sense. I'll give you one example. uh, like we humans, we actually associate color to different temperatures, such as red color for warm sensation and generally blue color for cold sensation. Even if you look at in your cars, you'll see that whenever you have to use the AC, then it is the blue, it is blue in color, and whenever we have to turn on the heater, it is red in color. So basically, this difference in temperature, it it actually can assist in the identification and discrimination of different objects um, by, for instance, it leads to evaluating the temperature difference between the human skin and the object in contact. So we can say that the material identification is further facilitated by evaluating the temperature profile and heat flux of the hand as a function of time. So, I mean, a lot of research has been going in this area, and some of the scientists have demonstrated that when the temperature difference between the object is relatively larger, it can facilitate better material localization and discrimination. Another scientists have established that thermal stimuli can strengthen emotions uh, induced by mechanical stimuli. So, for an instant, if you want to provoke a positive and happy emotion, so in that case, a vibrotactile thermal stimuli should be exerted at a high frequency and low temperature. And to provoke a negative and unpleasant emotion, the vibrotactile thermal stimuli should be exerted at a low frequency and high temperature. So actually, by what we say, by rendering the thermal sensations um, onto the virtual objects, the realism of augmented simulation can be significantly improved. And this has also led to the development of um, thermography. What is thermography? It is the enabled augmented touch interfaces. For example, by attaching the infrared cameras to the head-mounted displays, the thermal information of the surrounding environment can be collected and it can be overlaid onto the user's virtual view. Further, we can do is the residual heat from fingertip could be utilized to identify and distinguish the physical contact between the real objects and fingertips. So it is actually creating a 3D position of touch to to augment the interaction with both virtual and real objects. So this actually facilitates the what we say, the translation of any real object into a touch interface to interact with the virtual domain. So thermal haptic has been something, as you can see on the left. it is electrical and thermal energy, has been adopted into various commercial technologies and industrial applications. To give you an example, the experience of scuba diving, all of you know what is scuba diving, was was augmented utilizing what is known as Peltier devices and motion platforms. Just a minute. Just give me a minute. Is the PPT visible? The PPT is visible or not? Okay, so continuing with the thermal haptic, as I mentioned that it was actually adopted in various applications. So one of the experiences scuba diving. So scuba diving, in this we are actually using the Peltier device and motion platforms. So there are products like Thermover, which are utilizing Peltier devices to create the sensation of heating and cooling. Uh, in commercial products, I would say such as the Ambiotherm and Season Traveler wearable haptics were utilized to what you say augment the ambient temperature and create a realistic wind sensation. So most of the existing commercial thermal based augmentation technologies, they rely on visual displays and of the they are of the commercial thermal haptic and sensor devices to what you say it is they are being used to manipulate the human perception. Now the issues are that there is uh, there is a huge gap, what we say, between the state of the art thermal technology and the thermal devices which are utilized in AR applications. So it is a crucial actually, to what you say study and understand various state of the art thermal technologies and what do you say outline the guidelines for adaptation of these technologies in the augmented reality. Also, we need to address uh, the recent developments in the domain of thermal haptics and sensors. So basically, the thermal technology, as you can see, It has been categorized into two uh, categories. One is thermal haptics, which is called as the direct augmentation, and another is thermosensing, which is the detecting the heating flux. So, so these thermohaptics, they are further divided into Peltier devices, Tierra, all other things. Similarly, the thermosensing is also further subdivided into thermoresistive sensors. You can see here. Then pyroelectric sensors, then thermogalvanic sensors. So, in order, if you want to design a thermal haptic and sensor, which can effectively stimulate the thermal sensation, it is important actually to understand the various thermal properties of both the objects uh, and the human skin. That is something which is very important in case of in case of uh, wearables in augmented reality. Now, whenever wearable comes into picture, a lot of devices will come also. So antenna is a very vital component whenever you want to have the data transmission, data reception in case of wearables. So we'll discuss a little about antenna as well, and then lastly I'll be talking about the future scope of these variables. So far what we had discussed is something which is actually happening, and there's a lot of feature scope which is available in the case of variables. So that also we are going to discuss in detail. So let me discuss a little about the antenna, which is again a very vital component of variables. So I'll just change the slide. Give me a moment.
Sir, excuse me, sir. Your voice is not audible, sir.
Is it audible now?
Yes, sir. Now it is audible, sir.
I'm sorry. Okay. So I was mentioning that antenna is a very vital component in case of wearables. So the antenna serves to a communication system the same purpose that an eye and eye glasses serves to a human. So as I already mentioned in my previous, in the previous sections, that we want a wearable devices which are self-powered, which are flexible in nature, which can be implantable, which uh, which can be used for non-invasive purpose. So in all those things, one very vital component is an antenna. So let me give you a brief description about uh, a microchip patch antenna which is being used in these components. So a microchip patch antenna basically consists of three parts. There is a ground, there is a dielectric substrate, and there is a patch on the top. So this uh, three-layer structure is, and we actually like in the second or third slide, I had shown you a patch which was worn by an by the subject. So that patch is nothing but a patch antenna of flexible nature. So this microchip patch antenna, in their conventional form, they're not much useful, but they are being used in what you say, we made improvisations, modifications in the antenna, and they are being used now with. So if you go back to the history of the antenna, you'll see that the work on the antenna started way back in 1950s. So the first antenna was proposed by in 1950s, but for next 20 years approximately, actually no work, not a major breakthrough happened. But in 1970, there was one very I would say important event that has happened, which has led to uh, the use of antenna for the the communication and various other purposes. So that event was a workshop that was held in New Mexico in the 1979, and its proceedings were published later on in IEEE Transactions on Antenna and Propagation in 1981. So this was one of the most important event in the history of microstrip antenna, which has actually accelerated the work in the field of antennas. So this has led to what I say, uh, acceleration over the research in the field of antennas. So if you talk about antennas in their conventional form, as already mentioned, in conventional form they are not of much use because they have certain limitations. As you can see in this slide, the limitations are the low gain, the narrow bandwidth, and a large ohmic losses, then complex fading structures. So those are the all issues which antennas have. Their capacity to handle low power. These are the issues which an antenna has. And further, their unacceptability towards cross polarization and mutual coupling. So these are the issues. Now, why do we still use antenna? The the use of these microchip antennas are because of their applications in different communication systems and because of these salient features. So they have a small size, which we really want in our wearables, lightweight, easy handling capability, low production cost. So as I already mentioned, now the smart watches has cost has drastically come down. So every component which is being used in the wearable are responsible, and antenna is a one very significant component which is being used in the case of wearables. So the salient features are they are able to operate at multiple bands. They can offer various polarization. They have capability to attach, or they are conformable to any surface. So these features make them very suitable for communication system, particularly uh, today's topic of discussion is wearable. So they makes them very much useful in the case of wearables. Because of this, we are using antennas, microchip antennas particularly for wearables. So I'll not go into much detail. I'll just show you some of the antennas which are being used. So like any other field, we have challenges in the field of antennas as well. And the challenges are um, we want it to be used for wireless devices, but they should be um, economical and compact in size. They should be able to work efficiently for longer duration. They should be they should have we should be able to do the mass manufacturing. We want to do in large quantities, and they should be compatible with other components in the system. And also, we want the size to be reduced without any significant impact on its bandwidth. So these are the techniques which are used for majorly two things that we look for. One is size reduction, another one is improvisation in the bandwidth. So within the antenna also, these are some of the very popular techniques which are being used for size reduction as well as the bandwidth enhancement. So a use of a high dielectric constant substrate, then use of meandering in the patch, use of punching wires, then use of diodes. These are techniques which can lead to reduce in the size. Why we are talking about the size? Because in antenna, the frequency is inversely proportional to the size. So if you want to design an antenna for low frequency, the size will be bigger. But with those techniques, we can reduce the size and still we can achieve low frequencies. Similarly, the improvisation and bandwidth, these are the very conventional techniques. There are many more techniques which are available. So embedding suitable slot in radiating patch, then use of multiple closely spaced patches, than used of stacked patches one over the other. These are the popular techniques which are being used in the antenna. So these basically microchip patch antennas are the one which are being used in the wearable devices. So coming back to wearables. So coming to the last part, what is the future scope of wearables? So the first one is human performance enhancement. So these variables have, as I've already mentioned, shown also, they have come as a potential tool for enhancing the human performance. This could be in various domains. And the domains could be sports, athletics, uh, like in athletics, if you say that the you can optimize the training routines, we can monitor the performance metrics, and we can prevent injuries with wearable technologies. Similarly, in the workplace, wearables can enhance productivity and also the well-being. It can reduce our stress. It also promotes ergonomics practice, and also it can track your cognitive fatigue. So the scope of what we say human performance enhancement, it actually extends beyond physical domain. It can also lead to it goes into the mental domain, into emotional resilience, and so they make variables indispensable for optimizing what we say human potential. Another part which it can take up is for we can use variables even for our data security and privacy. So variables actually handles, uh, since we are saying that we are actually acquiring the data. So this data is actually very sensitive health data. So we must ensure its security and privacy. So that's a future scope. So although it leads to human performance enhancement, but we should also look for the data's security and privacy of uh, of the data. So healthcare organizations and device manufacturing companies, they must actually implement a robust what you say data encryption and data security protocols, which should safeguard the patient's confidential information. And there should be data protection regulations. There could be a health uh, what we say there could be a health insurance portability and accountability act to actually maintain the ethical data practice, and to what you say develop trust among the users. So as I already mentioned that variables are we use biosensors for precision of our health, and we had also mentioned about we can use the variables for smart fabrics and e-textiles also. So smart fabric, that was the area which I have not covered. This could be also considered in the future scope. So the actually what we say the convergence of wearable technology and smart fabrics, which are also known as e-textiles. This is again a very exciting frontier, and it has got a lot of potentials. So e-textiles actually they have to be embedded with sensors and microelectronics. Then only they can offer a seamless integration of wearable devices into our everyday apparels. So far apart from these fabrics which are used for aesthetics, it can also be used for monitoring the vital signs, postures. Even they can be used for variables can be used for like I've mentioned here, environmental monitoring and sustainability. So they can be used for uh, uh, noting down the air quality and UV exposure. So what I want to say that the incorporation of e-textiles into wearable devices can make a significant milestone in the diverse industries which are ranging from fashion to sports to military, and it goes beyond. So these are, I mean, the areas. Now coming to the neural interface of the wearable. So with the advancement of neural interface variables, a new era which is called as a human computer interaction that is going to come. So these wearable devices will actually facilitate direct communication between the human brain and external technologies that actually allows for uh, emergence of brain control wearable devices. uh, we can imagine a future where wearable devices can be operated simply by thought, or sensory feedback can be directly delivered to the brain uh, through neural interface variables. So basically, these technologies will be helpful in assisting individuals with disabilities. It will also enhance the cognitive function and also led to fostering the new dimensions of human connectivity. Further, if we check out, the variables, variables actually have the biosensors. So this can actually lead to what we say that it can revolutionize our precision health. So these highly advanced biosensors, they are actually proficient in analyzing the biochemicals and what we say the physiological markers. So they actually offer the ability to monitor and an individual health in real time with exceptional accuracy. So the incorporation of such biosensors into the wearable devices, it can enable us the early disease detection, and there is also a provision of what we say personalized treatment strategies which could be based on individuals unique uh, health profile. So with the use of wearable biosensors, the healthcare standards that are going to change. It will empower individual to optimize their well-being, and also it will enhance the healthcare providers' capacity to deliver the targeted or uh, the things which we are aiming at. Further, we are coming to the variables which could be used for environmental monitoring and sustainability. So these variable actually extends their impact beyond precision health, as I had already mentioned, to environmental monitoring and sustainability as well. So we can design wearable sensors for detection of pollutants. I already mentioned about measuring air quality. Uh, we can monitor the environmental parameters in real time, which allows us to offer a novel approach to active participation in what do you say environmental conservation efforts. So the convergence of wearable technology and sustainability could mark a very significant milestone towards fostering the eco-conscious decision making and environmental sustainability. So wearable devices also plays a very important role for environmental monitoring and sustainability. Now, talking about variables in AI assistance and emotional intelligence. So, variables AI assistance actually they are the areas where the personalized emotional support and mental well-being services could be offered. So, in future we may have these intelligent companions which possess the ability to comprehend and respond to users emotions, uh, providing what we say that the tailored coping strategies. We can have mindfulness practices and emotional coaching. So beyond their significance, I would say in mental health care, wearable AI assistance can also lead to a meaningful social interactions and also nurturing the emotional connection between the users. One of the example is like wearable brain computer interface. So brain computer interface is something which is a new era of cognitive enhancement and brain augmentation. So this brain computer interface this can be integrated into wearable devices uh, that can help to augment the cognitive capabilities. uh, it can be used in supporting memory, learning, and problem solving. So the what you say the implications of wearable brain computer interface are far-reaching. It can be extending to the assistance of individuals with cognitive impairments. It can also enhance the what do you say neuro rehabilitation processes and also enhancing harmonious human machine collaborations. So I mean these are the what do you say areas where we expect where the future scope of our wearables lie. So with this I want to also I want to come to the conclusion part. So there are certain ethical considerations also. As we are talking about the future scope, we have to take care of the ethical considerations. So as we are what we say contemplating to the transformative future of the wearable devices, we should take the ethical considerations also to the center stage. We have to, as I already mentioned, we have to do the safeguarding of data, secure it, or there should be what we say equitable access should be there to such that the wearable technology will benefit all individuals responsibly. And what we require is a collaborative efforts between in academia, industry, policymakers, and healthcare professionals to establish ethical guidelines and a regulatory framework that could preserve actually the users' rights while we are fostering for the innovation. So what I could say is that together we can forge a path towards a future where the wearable devices serves as catalyst for the positive change. It can be used for empowering individuals and shaping a healthier, or what we say, a more connected world. So as we know that while the wearables they offer immense promises, there are certain challenges also. So we have got several challenges, I would say, particularly for wearable devices. Data accuracy is something which is a critical concern. I've already mentioned 2 to 3 times about it. That and security and accuracy are something which are of primary concern. First, we'll take up the accuracy. As inaccuracies in health monitoring data, it can lead to incorrect medical decisions. So that is very important. Battery life is another challenge. So we have to make our wearable devices self-powered. So as longer battery life durations actually would improve user experience, and it would reduce the frequent recharging needs. So we have to make our wearable devices self-powered. So in addition to that, what we can mention is that as, I mean the the future of wearable devices is quite bright, because a lot of ongoing research and advancement is going on, and we have to overcome these challenges, particularly related to data. There is a lot of advancement which is going on in the sensors technology. A lot of advancement is going on in the field of antennas, which I already mentioned that is a very vital component. Nowadays, we are using antennas which are reconfigurable. Reconfigurability is here considered into uh, 3 ways. One is antenna which is frequency reconfigurable. That means the same antenna could be used to operate at different frequencies, and that switching is being done by using can be done mechanically also, it can be done electronically also. So that is one part, frequency reconfiguration. Another part is the pattern reconfiguration, because in the field of antenna, we know that antennas are generally have a directive radiation pattern. That means they are directional. They are bound to operate in a certain direction only. So when you have reconfigurable pattern, that means you can make the same antenna work to radiate in different directions by switching. So again, that switching is also electronic and mechanical. The third type of reconfiguration is where you have polarization. So basically polarization is of 3 types: linear, circular, and elliptical. So you can make your antenna work in different polarization, same antenna, again by electronic switching or mechanical switching. So these are the 3 reconfigurations which are possible, and we can have combinations of the two. That means we can have an antenna which is frequency and polarization reconfigurable. We can have an antenna which is frequency, polarization, and pattern reconfigurable. So this is what I say, that advancement which is going in the field of antennas. We are making antennas, or antenna integrated systems which are self-powered. Similarly, there are advancements which are going in the field of artificial intelligence, we all know, and data analytics. So this will actually pave the way for more accurate uh, data capturing by the variables, and that leads to actually a meaningful health insight. So in future we are expecting that the wearable devices are likely to become even more sophisticated, incorporating additional health metrics, and it is seamlessly integrating with other medical devices and platforms. So as a result, they will play a more prominent role in early disease detection, personalized medicine, and popular health management. So in near future, what I wanted to say is that wearable devices will become a very indispensable tool in the field of healthcare, in the field of communication. It will be significantly impacting the patient care, remote monitoring, and telemedicine. Also, from from continuous health tracking to facilitating virtual medical consultations, wearables have actually transformed the way we approach healthcare, and it'll bridge the gap into healthcare accessibility. As the technology continues to evolve, it is crucial for healthcare professionals, researchers, and policymakers to collaborate and harness the potential of wearable devices in what you say, advancing the digital health. So by embracing these transformative technologies, we can build a future where, I mean, we will be surrounded by these variables, and it will improve our quality of life. So with this, I want to end my lecture. I'm open to any questions if anyone has. These are the references. Thank you. Any questions?
Sir, we are waiting for questions, sir. If any questions are there, I will let you know, sir.
Okay.
I request all the participants, if any questions are there, please post in the chat box. So here we have one question, sir.
Yes.
Hello, sir.
Yeah.
Sir, question,
Can
sir.
you hear me?
Is there any
Yeah.
side effects to brain nerves if neural interface or biochips are used?
Ma'am, we are surrounded by technology actually. So if we use it for a limited duration, then it will not affect. Like if I give you an example, like we do the CT scan, MRIs. So limited use are will not affect. Obviously, it has ill effects, but you have to limit the use. Like another example I'll give you, in our mobiles we have, every mobiles now they come up with a by, I think I've lost connection. No, it is restored. Can you hear me? Am I
Yes, sir, we
audible?
can hear you. Yes, sir, we can hear, sir.
Yeah, so I was saying is, in between there was a disruption due to disconnectivity. So what I'm saying is, SAR, the prescribed rate of, the value of SAR is 1.6. Uh, I think 1.6 is the value which is prescribed. It should be below 1.6. So if we go by the calculation, everyone should not use, no, you should not use more than, at a time, you should not use for more than 6 minutes. And the total duration, for in a duration of 24 hours, you should use mobile for 30 minutes. That's the prescribed value given to us. But do we follow that? No, we don't. So what are the solutions? We can use, if we can't stop because there is a job requirement, there are other compulsion which may not allow you to be well within those limits, then in that case, what you could do is you can use earphones, or you can limit, you can talk for short duration, you can use messaging, all those things could be used. Yes, so like there, it has an ill effect, but if you use them in limit, then it will not have so much adverse effect.
Sir, we have another question here, sir.
Yes,
Which type of software is best for designing of wearable antenna?
you can, there are various softwares available. HFSS is there, CST is there, now some ADS is there, and FICO is there. MATLAB has also come up with their tools which are based on antenna. So whatever is available uh, in your institution or your organization, you can use it. There's so many tools now available on antenna. The one which I have mentioned are the popular ones.
Sir, another question from a participant, sir.
Yes.
Do the polarization affects the radiation pattern in wearable antennas?
It depends, ma'am, what polarization we are aiming at. Like if your transmitting device has a linear polarization. Linear also we have got two types of polarization, which is vertical, another one is horizontal. And say you are using horizontal polarization, the transmitting device, and the receiving device is using vertical. So if the polarization is different, the receiver will get only a minimum amount of power, or negligible amount of power. So polarization, in what context you are asking, it has different, as I already mentioned that we can have now antennas which have reconfigurable polarization. So you can, the same antenna could be used for linear. Within linear also we can have horizontal, vertical, could be used for circular polarization also, could be used for elliptical polarization also.
Sir, we have another question, sir. What is the minimum size of the wearable antenna?
It depends on the application, ma'am. Like we have been using smartwatches. Antenna is there in the smartwatches also. We are using antennas. Fastags also has an antenna also. Now we are coming with nano antenna. I've shown you an endoscope capsule also. It has a very small size antenna. You can imagine antenna within a capsule sort of structure. It all depends on our application. We are going up to very size that may not be visible by naked eyes.
Sir, now we will proceed for vote of thanks, sir.
Okay.
Now
Thank
it's
you.
time for vote of thanks. On behalf of organizing committee, I would like to extend a heartfelt vote of thanks for Day-4 session to all the esteemed faculty members who participated in this enlightening FDP. I would like to apologize on any difficulties and discomfort you may have experienced during the session. Sir, we have gained so much of valuable insights and knowledge on wearable antennas. I thank everyone for attending this FDP and also join on the day 5 Monday. Thank you to all. Sir, thank you so much, sir.
Thank you. I would like to thank the Gates, the management of Gates Institute of Technology, my colleague Dr. Archit Proveen, and all other participants, faculty members for giving me opportunity to deliver a lecture, share whatever knowledge I have. Thank you.
Thank you, sir. Thank you so much, sir.
Okay.
See you again on Monday
Feedback.
for day 5 session. Feedback link will be posted in the WhatsApp group. Thank you to all.